Good morning, students, and welcome back after our vacation. We have a big day today, so I'm going to go a little bit quick in the beginning so that I can get to our lesson. For our Do Now, you have a prompt about pathways and careers. We'd like you to respond to that. And for our objective, we will factor trinomials. We did that before the vacation, but this time we have a leading coefficient, and that makes all the difference. So our essential questions are: what method can I use to accurately factor a second-degree trinomial with a leading coefficient? Okay, so these are trinomials, three terms that have a have a power of 2 in them. And also, why should I look for a greatest common factor first? So our assignment for today is to complete the Do Now, the 2 assigned pages, and the exit ticket. If you are a distance learner, you'll submit your work under assignments on Teams. If you are in person today, I will walk around and give you credit for your work, and I'll put that into Teams. So we have homework, and you will need this practice. I've said this to you before. These lessons that we're doing now, the factoring, especially today's lesson and the lessons over the next couple of days, to the extent that you do these lessons well, is the extent to which you will do quadratics well in our next unit. So we're factoring trinomials of the form ax squared plus bx plus c. That a is the leading coefficient that I talk about. So homework 8 for tonight, please get that extra practice. Also, be mindful of due dates for quarter 4 because you won't have any extra time to turn things in. So let's stay on top of it. And plus, students, with the nature of this work, with what we're covering, you really don't want to let things go. So we'll get back to our exit ticket in a few minutes. Our Do Now is about pathways and careers. What are the advantages of discovering your professional life vision when you are young? And I think, I think one of the advantages is that you can begin learning about your profession sooner. You can start listening to blogs, reading newspaper articles, on internet articles, magazines, journals about your chosen profession. You can also figure out, well, maybe I don't like this as much as I did. So, it's a good thing to find out when you're young. You can start meeting people who can mentor you in a profession that you're considering making your own. There's all kinds of reasons to really begin thinking about this when you're young. So let's get started with our lesson. So we're going to start with a warm-up. We factored trinomials before we went on vacation. And in doing so, we looked for two numbers that add to the b value. Remember, these are a squared plus bx. Let's write that neater. A squared plus bx plus c. And remember, those pluses can be pluses or minuses. So we're looking for something that adds to 14 and multiplies to 45, two numbers. And in this case, those two numbers would be 9 and 5. And let's also remember to look at the signs. So we're going to have a positive 9 and a positive 5 because 9 plus 5 equals 14 and 9 times 5 equals 45. So our factored form of this expression would be x plus 9, x plus 5. Remember, multiplication is commutative, so order does not matter. If you put them in reverse order, that's fine. So n squared minus 3n minus 28, we want two numbers that add to negative 3 and multiply to negative 28. So if we had a negative 7 and a positive 4, that would add to 3 and multiply to negative 28. So n minus 7 times n plus 4 factors to this trinomial. And if we FOIL these terms, first, outer, inner, last, we will get back to our original trinomial. Now, in case of 3 and 4, we see that there is a greatest common factor we can factor out. So let's do that. So when we factor out 2, we have a squared plus a minus 12. Also look carefully at these signs. Okay, we have a plus and a minus. So if we're going to multiply to a minus, we should have a plus and a minus in those two numbers that we decide. And certainly if, excuse me, students, if we want to add to positive 1, we have, because this is an invisible 1 in front of the a, multiply to negative 12, we're going to need a positive 4 and a negative 3 to do that. So that would be, so now we're not factoring, we're not working with the 2 stays on the outside. We're working with a squared plus a minus 12. So we have our factored out 2, and then it would be a plus 4, a minus 12. And if this is looks a little foreign to you, go back and review the last lesson. This is just a review of what we've already done. In the case of number 4, we'll factor out that 4, and we'll have p squared minus 6p plus 5. And we have a minus and a plus, so it looks like we're going to have two negative terms. We want to add to negative 6 and multiply to positive 5, so that's got to be a negative 5 and a negative 1. They will add to negative 6 and multiply to positive 5. So we have our factored out 4, and we have our p minus 5, p minus 1. And that's our final answer there. So with that in the back of our heads as we begin our work today, we're going to look at those kinds of trinomials that have what we call a leading coefficient. So look down here, we have ax squared plus bx plus c. We've got a leading coefficient here that we need to deal with. Now, if you go onto the internet, you're going to find probably 20 different ways to do what we are doing today. And I've done a few of them. I like slip and slide. I think it's pretty simple, and I think it will. I think it'll work for you. So I hope it's the method that you like. If you do find another method, make sure you know it well. I prefer slip and slide. So here's what we do. We have this a term. We're going to slip the a term to the end of the trinomial, and we're going to multiply it by the c term. So a will multiply by c. Now you're going to factor the new trinomial, which no longer has that leading coefficient. And you'll factor it by finding two numbers that add to b and multiply to the c, just like we did before. Now we're not done. After you've factored this new basic trinomial, you're going to divide both of the factors, okay, the numbers, by the value that you slipped in step 1. So you have to remember what that was. You'll go back and look at the original trinomial to determine that if you forgot. And then finally, you'll end up with fractions, usually. And you'll reduce the fractions. And then if the fraction has a denominator after you reduce it, some will, some will not, you slide the denominator up next to the variable. And you can check your work again by distributing. So let's go slowly and let's look at example 1. So we're going to slip 2 to the end of the trinomial and multiply by 3. And our new trinomial is x squared plus 5x plus 6. Now we're going to factor this as we did last week. So I need two numbers that add to 5 and multiply to 6, and that would be 3 and 2. So that would be x plus 3, x plus 2. But I'm not done yet, okay? Now I have to take, so this is step 2. I've done step 1. I've done step 2. So now step 3, let's get a new color. I'm going to divide both the factors by the value that I slipped in step 1. Well, what was the value I slipped in step 1? The value was this leading coefficient of 2. So I'll divide 3 by 2, and I'll divide 2 by 2. Now I'm going to reduce the fractions. Now 3 over 2 does not reduce, but 2 over 2 reduces to 1. And then I'm going to take this amount, this number that I divided by any remaining denominator I have here. So I've got here a remaining denominator of 2. I'm going to take that 2, I'm going to slide it back up in front of the x and rewrite my factored trinomial, which is now no longer a trinomial. So 2x plus 3, and then the right side binomial x plus 1. And that's the answer. And if you take 2x plus 3 times x plus 1, and you FOIL that, you will end up with 2x squared plus 5x plus 3. So let's take a look at number 2. Slip and slide. Here we go. We're going to take the 5 and multiply it by 6. That will give us m squared minus 17m plus 30. Now we need two numbers that multiply to negative 17. Add to negative 17 and multiply to 30. We've got negative 17, positive 30. So that would be negative 15 and negative 2 will add to negative 17 and multiply to 30. So let's factor that. So we've got m minus 15, m minus 2. Okay, so far so good, I hope. Now we're going to divide by the number that we slipped, that leading coefficient of 5. So we'll divide that by 5, and we'll divide that by 5. Now, after we divide that by 5, we end up here on the left side, we end up with m minus 3, because 5 over 15 reduces to 3, and m minus 2 over 5. That's where we are now. We're not done yet. Now we have a denominator in the second binomial. So this denominator needs to come up in front of the m. So let's rewrite this again. We have our m minus 3, and then now with 5 sliding up in front of the m, 5m minus 2. And that is a final answer. And if you FOIL that expression, you will end up back at 5m squared minus 17m plus 6. So why don't you try 3 and 4 on your own? Just be mindful you've got 2 negative signs there. Okay, I hope you tried it. So let's go. We're going to slip 6 over to the negative 4, multiply, and write what we have so far. So that would be y squared minus 5y. Positive 6 times negative 4 is negative 24. Okay, now we need two numbers that add to negative 5 and multiply to negative 24, and that would be negative 8, positive 3. So let's factor this trinomial that we have so far. So y minus 8, y plus 3. Not done yet. So now we're going to take that initial leading coefficient of 6 and put it as a denominator under the negative 8 and the 3. Now, can we reduce this? Well, we certainly can. When we reduce this, we're going to have y minus, and 8 divided by 6 reduces to 4 over 3, and y plus 3 over 6 reduces to 1/2. Okay, next we need to take the denominators, and we have 2 of them this time, and slide them in front of the variables y. So let's rewrite that a final time. 3y minus 4, 2y plus 1. And that is our final answer. How did you do? Okay, example 4, 12c to the second power plus 11c minus 5. We'll multiply 5, the negative 5, and the 12. So we're going to slip that 12 over. 12 times 5 is 60. So our new trinomial, c squared plus 11c minus 60. And I need a number that adds to 11 and multiplies to negative 60. So I'm going to need a positive number and a negative number. Well, 15 times 4 is 60. One of them has to be negative. If I want them to add up to 11, I'll need a negative 15 and a positive 4. So that'll work for me. So I'll factor this trinomial, c plus 15, c minus 4. And now I need to take that, that leading coefficient of 12 that I started out with, that I slipped over to the c value of negative 5. I need to take that and make that the denominator. And now I want to simplify these denominators. So this is going to be divided by 3. This is going to be divided by 4. So I will have c plus 5/4, and I will have c minus 1/3. All I did was reduce the fractions. Now those denominators are going to come back up and slide in front of the c, and then I will be finished. So I will have 4c plus 5, 3c minus 1 as my final answer. How are we doing? Quite a few steps there. I'm going to get a sip of my coffee, fortify myself before we go on. Okay, so here we go. I'm going to do all of these. If you do them all without my help, please make sure you stop here before you get to the examples with the greatest common factor, unless you really want to challenge yourself and try those on your own. But I'm going to do every problem so you can check your work. So you can either work together, or why don't you try a couple on your own and then come back to the video and see how you did. Great job. So here we go. Number 1, we're going to take the 3 and slip it next to the 10, multiply it by the 10. And when we do, we have x squared minus 11x. Be so mindful of these signs, plus 30. We need two numbers that add to negative 11 and multiply to 30. Positive 30, negative 11x, I'm going to need two negatives. So that would be a negative 6 and a negative 5, because negative 6 plus negative 5 equal negative 11, negative 6 times negative 5 multiplied to 30. So that brings me to x minus 6, x minus 5. Now I need to take the 3, the leading coefficient, and put it as a denominator under that 6 and under the 5. And when I reduce those fractions, I have x minus 2, x minus 5/3. So in the first one, I do not have I'm not going to have a leading coefficient because I don't have a denominator. But in the second one, I'm going to slip that 3 up in front of the x. So that will give me x minus 2, 3x minus 5. Done. Number 2, multiply. I'm going to slip the 8 next to the 3 and multiply, so I will have y squared minus 10y plus 24. I need two numbers that add to negative 10 and multiply to 24, and so I think negative 6 and negative 4. They add to negative 10 and they multiply to 24. So y minus 6, y minus 4. Now I'm going to take the leading coefficient of 8 and use it as the denominator with the negative 6 and the negative 4. And when I reduce those fractions, I have y minus 3/4 and then y minus 1/2. So I'll take the 4, slip it in front of the y in the first expression, take the 2, slip it in front of the y in the second expression to give me 4y minus 3, 2y minus 1 as our final answer. So number 3, we'll slip first, and we have m squared plus 3m minus 18. I need two numbers that add to 3 and multiply to negative 18. So it's going to be a positive and a negative. And if I have a positive 6 and a negative 3, they will add to 3 and multiply to 18. So m plus 6, m minus 3. Now I'm going to go to that original leading coefficient of 9, and that becomes my denominator. And I will simplify m plus 2/3 m minus 1/3. And now I'm going to have two leading coefficients in my final work, because the 3 will slip in front of the m in the first and second. They're both going to have 3 m's. So I end up with 3m plus 2 and 3m minus 1 as my final answer. Remember, you can always check them by using FOIL, first, outer, inner, last. Number 4, let's multiply 10 by negative 2 to give us p squared minus p minus 20. I needed two numbers that add to negative 1 and multiply to negative 20. So that would be a negative 5 and a positive 4 add to negative 1, and negative 5 times positive 4 equals 20. So now we have p minus 5, p plus 4. Now we're going to take that leading coefficient of 10 and use it as our denominator in both of those binomials. Then we will reduce the fractions, so p minus 1/2, p plus 2/5. And now we'll take the denominators and we'll slide those in front of the variable p, and our final answer will be 2p minus 1, 5p plus 2. How are you doing? We have two more of this type, and then we're going to challenge us with 4 that are a little more difficult and have a few more steps. So number 5, we slip the 4 next to the 1 and we multiply, which gives us a squared minus 4a plus 4. And we need two numbers that multiply to negative 4 and add to 4. So -2 and -2 would work for us. -2 plus -2 add up to -4, and they multiply to +4. So a minus 2, a minus 2. Now we're going to take that leading coefficient of 4 and use it as a denominator in both of these binomials. And we'll reduce these fractions, so it would be a minus 1/2. And then we'll take that denominator of 2 and we will slip it in front of the a. And when we have something that looks like this, we have 2a minus 1 times 2a minus 1. We can rewrite that as 2a minus 1 squared. And I hope you caught that. And number 6, we'll slip 6 next to 12 and multiply to give us x squared plus x minus 72. I need two numbers that add to 1 and multiply to 72. And the larger number will be positive because I have an invisible positive 1 in front of that x in the middle there. So if I have a positive 9 and a negative 8, they will add to positive 1 and they will multiply to negative 72. So x plus 9, x minus 8. Now I'm going to take that leading coefficient of 6 and use it as a denominator under the 9 and the 8. And I will simplify my fractions. X plus 3 over 2. Doesn't matter that it's an improper fraction, that's okay. X minus 4 over 3. And now I'm going to take those two leading coefficients, the 2 and the 5, and slide them in front of x, which will give us 2x plus 3, 3x minus 4, and that is our final answer. Okay, good job. We have 4 more, but they're going to challenge us a little bit more. So with examples 7, 8, 9, and 10, you're going to look for a greatest common factor first. Then you're going to factor the remaining trinomial using the slip and slide method. So when I look at 10k squared, number 7, 10k squared plus 75k plus 35, I can factor out a 5. So let's do that. So when I factor out the 5, I have 2k squared plus 15k plus 7. Okay, now I still have a leading coefficient of 2 in the trinomial. For the next couple minutes, we're going to ignore what we factored out and work with the trinomial 2k squared plus 15k plus 7. We're basically doing everything we did in the first 6 problems. So I'm going to slip 2 next to the 7 and multiply. So I have my leading greatest common factor of 5, k squared plus 15k plus 7 times 2 is 14. Now I'm looking for two numbers that add to 15 and multiply to 14, and that's 15 and 1. 14 and 1. 14 plus 1 is 15, and 14 times 1 is 14. So I still have my greatest common factor. Then I have my k plus 14 and my k plus 1. But we're not done. We still have to deal with that leading coefficient of 2. So do you see how we've factored out the 5, and we really do ignore this 5 for now? We're looking at the leading coefficient of 2, And that's what we divide the 14 and the 1 by. Now let's just simplify those fractions. So we have k plus 7, and then k plus 1/2. Now, in the case of the second binomial, we do have a denominator of 2 to slip in front of the k. So we have 5 times k plus 7, and then our second binomial, 2k plus 1, and that is the final answer. Okay, so number 8. So everything, I would say everything is the same from this point on that we've been doing, but we've factored out a greatest common factor first, and then you just work with the trinomial that's left. So let's factor out a 2 in 12x squared plus 2x minus 2, which would give us 6x squared plus x, and remember that's 1x minus 1. Now we need a number, two numbers that add to 1 and multiply to negative 1. So that would be a positive 1 and a negative 6 could do us. Let's see. Oh, I skipped a step. Hang on, not there yet. We have to slip and slide first. Sorry about that. Forgot about my 6. Let's slip the 6 next to the negative 1 and multiply. X squared plus x minus 6. Okay, now we need two numbers that add to negative 1 and multiply to negative 6. So I think in this case, they have to multiply to negative 6. We'll need a positive and a negative, and they need to add to 1. So that's going to be positive 3 and a negative 2. So we factored out the 2, and we have x plus 3, x minus 2. Now we need to put our leading coefficient of 6. And when I say leading coefficient, I'm talking about this one. It's kind of like a new leading coefficient that we created once we factored out the 2. So we'll put that as the denominator under the 3, the negative 2. I'm just going to reduce those fractions. So that would be x plus 1/2 and x minus 1/3. Now we've got two denominators that will get slipped back up in front of the variable x. We have that 2 and we have the 3. So our final answer will be the greatest common factor we factored out of 2 times the quantity of 2x plus 1 and 3x minus 1. And that's our final answer. And how are we doing? Are you going to tackle 9 and 10 on your own? Let's see. Go ahead and do them. Pause the video if you'd like to try them on your own. But I will be doing these. Okay, so number 9. Let's factor out a 3, which would give us 5y squared minus 6y minus 8. Now we're going to slip and slide. So 5 times negative 8 would give us y squared minus 6y minus 40. I need two numbers that add to negative 6 and multiply to negative 40. So if they multiply to negative 40, it's going to be a negative and a positive. So negative 10 and a positive 4 will multiply to negative 40 and add to negative 6. So 3y minus 10, y plus 4. And let's work with that leading coefficient of 5. So we'll divide everything by 5 and reduce the fractions. 3y minus 2, y plus 4/5. So I have one denominator that I will slide back up in front of the y, giving me a final answer of 3 times the quantity of y minus 2, and then the quantity of 5y plus 4 as a final answer. Great job. And then number 10. So all we can factor out is a 2, which would leave us with 16w2, w squared, minus 8w plus 1. So I need two numbers that multiply to 1 and add to negative 8. Oh, not yet. I'm sorry, I forgot to do my slip and slide. 16 times 1, 2 w squared minus 8w plus 16. Okay, now I need two numbers that multiply to negative 8 and add to 6, or multiply to 16 and add to negative 8, excuse me. So I'm going to need two negative numbers because they need to multiply to positive 16. So negative 4 and negative 4 will add to negative 8 and multiply to positive 16. So 2w minus 4, w minus 4. I think you see what's going to happen at the end of this problem already. So let's divide both of those numbers by our leading coefficient. Remember, our leading coefficient is the 16. So we're going to divide these by 16 and rewrite. We'll reduce the fractions, so that would be w minus 1/4, w minus 1/4. So we did our slip. We now need to do our slide. The 4's will come up in front of the w's, and we will have 2 times the quantity of 4w minus 1, 4w minus 1, which we can rewrite as 2 times the quantity of 4w minus 1 squared. So it's quite a lesson. How did you do today? I do want to go back to our exit ticket and review those steps. So slip A to the end of the trinomial, multiplied by C. Okay, factor the new basic trinomial. Okay, divide both factors by the slipped value. And then reduce fractions and slide the denominator in front of the variable. Now, you won't always have a denominator, but where you do, you have to slide the denominator up in front of the variable. So great job today. I appreciate your hard work, and I appreciate so many of you want to finish algebra strong. This particular lesson does take a lot of practice, so please do your homework tonight. And as always, with that practice, you'll be great.